This is lesson 9.3, Order of Operations. This is page 249. The essential question reads, how do you use the order of operations to simplify expressions with exponents? I'm going to go ahead and let you know right now that another word for simplify is solve. If you see that you're supposed to simplify, that means you can solve. Okay? So let's check out the order of operations. Surely you've been exposed to this before, whether you recognize it or not. So exploring the order of operations. Number 1, perform all operations in parentheses. Number 2, find the value of numbers with exponents. Multiply or divide from left to right, and then add or subtract from left to right. A lot of people remember this using one of two expressions, either PEMDAS, parentheses, exponents, multiply and divide, they go together, add and subtract. Or people know the expression, please excuse my dear Aunt Sally. Either way, it always reminds us to always check for parentheses, then exponents, then multiply and divide, then add and subtract. So we're going to check that out within the context of an Explore activity. This gets a little bit complicated, but I'm going to simplify it as much as I can, and I'm going to help you read it. Amy and 3 friends launch a new website. Each friend emails the web address to 3 new friends. These new friends forward the web address to 3 more friends. If no one receives the email more than once, how many people will receive the web address in the second wave of emails? So the first wave, they show a picture of it, is that Amy emails 3 people. Well, this is a person right here, and what does this person do? This person sends 3 emails. 1, 2, 3, and at the end is a person. And this is the first person that Amy emailed, this is the second person she emailed. And this person sends 1, 2, 3 emails. And this is the third person that Amy emailed, and she sends 1, 2, 3 emails. So one thing you're supposed to do is sketch this, because it says right here, use a diagram to model the situation for Amy. Each dot represents 1 email. Complete the diagram to show the second wave. So you need to do this, what I did. And then question B says, complete the table to show how many emails are sent in each wave of Amy's diagram. Well, the first wave was Amy, and how many emails did she send? 3. And written as a power, 3 is written 3 as the power of 1. The second wave, this is what the question asked all along, is the second wave. Amy is just one of 4 friends initiating the first wave of emails. Oh, I'm not there yet. I'm still on 2. So I'm still on B. Sorry. I'm on the second wave. Well, the second wave is what? It's 9 people. How many emails were there? 9. And you can count those up. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, how is that written as a power? Well, it's those 3 people, and they each sent 3 emails. So that's 3 to the second power. I know you might be tempted to write 3 to the third power, but 3 to the third power would be the third wave, and we're going to actually answer that later. The third power would be how many people? Well, that would be 27, because each of those 9 people sent 3 emails. 9 times 3 is 27, and that would be 3 to the third power. We're going to answer that. It's the first question on the next page, actually. Alright, so question C says, Amy is just one of 4 friends initiating the first wave of emails. Write an expression for the total number of emails sent in the second wave. So how many people are doing this? 4 people are doing this. So this number right here is actually going to be a 4. And each of those people have one of these things right here, like Amy does. And in the second wave, it's 3 to the second power. We know that because check it out. This is the wave right here. And the power is 3 to the second power. 3 times 3 is 9. So question D says, identify the computation that should be done first to simplify the expression in C, then simplify the expression. Well, what are we supposed to do first? Are we supposed to do 4 times 3, or are we supposed to find the value of 3 squared? Well, this is a PEMDAS question. And so let's go ahead and look at all our operations. We don't have any, if we look at our math problem here, we don't have any parentheses. But we do have exponents, and exponents comes before multiply. So notice that this is a problem, and this is a problem. So you could either do 4 times 3, or you could do 3 squared. And what you got to do is 3 squared first. Now why do you do that first? Because over on PEMDAS, E comes before M. Exponents get done before multiplication. So then right below it, we're supposed to solve. says the value of the expression is 4 times, well, I'm going to do this right here. I had 4 times 3 squared. 3 squared, which I already know is 9. I already did that earlier. So this goes here. It's 4 times 9 is 36. Now, how'd they get 46? Well, that image we just drew of Amy, remember that image we had of Amy, how she initiated 9 emails? It looked like this: 1, 2, 2, 3. And then 1, 2, 3, 1, 2, 3, 1, 2, 3. If you're wondering how the answer is 36, because it says Amy is just one of 4 friends. So we've got Amy, we've got another person that would have 9, we have another person, we have another person. They're all starting the website together, and they would each have that same diagram. So how many emails would that be? Well, it would be 4 times 9, which is 36. That's how we get to 36 here. All right, we're going to actually go and do the reflect at the top of page 250 right now on the same video. It says reflect number 1. In B, why does it make sense to write the numbers of emails as powers? What is the pattern for the number of emails in each wave for Amy? So what we had was, we had the first wave, and that was 3 emails, and it was 3 to the first. And we had the second wave, and that was 9 emails, because it was 3 times 3, that's 9. That's 3 to the second. The third wave would be 27, because it's these 9 people that all send 3 emails. 9 times 3 is 27. That's 3 to the third. What would the next one be? The fourth wave would be 27 times 3, that's 81, and that's going to be 3 to the fourth. So let's go ahead and answer the question. Why does it make sense to write the number of powers as emails? Well, do you notice here that this 2 matches this 2, and this 3 matches this 3? So we're going to write a couple things here. One is the wave number matches the exponent, and the pattern would be, we already kind of wrote it, would be, and I'm going to handwrite it because I can't type this in. It'd be 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, and it just goes on forever. That's the pattern. Okay, we're going to stop this video here. Well, you know what? We're not. I changed my mind. We're just going to make this video be 2 pages. We're just going to make this video be 2 pages, no problem. We're on simplifying numerical expressions. A numerical expression is an expression involving numbers and operations. You can use the order of operations to simplify numerical expressions. So on all of these right here, I'm going to, off to the side, check to make sure we're doing PEMDAS. Parentheses first, then exponents, then multiply and divide, then add and subtract. And let's go ahead and examine the work and make sure they're doing it right. I like to use, so you're not going to solve these. We're just going to kind of examine these. So I like to use carets on this. Watch what I do. I'm definitely not going to add here, because if you go to PEMDAS, add's near the end. And I'm actually not going to divide. A lot of kids went on to divide. I'm going to do the exponent first, because here's what I've got in A. I've got an exponent, I've got division, and I've got add. So I've got exponent goes first, then division, then add. That's what I'm going to do. So exponent first is 3 squared. 3 squared is not 6. 3 squared is 9. Now I actually bring down the rest of the problem. So I recopy it as 5 plus 18 divided by 9. And then I do what's next is divide. 18 divided by 9 is 2. And add 5 is 7. So I'm going to go ahead and erase and clear my board and move my board and make sure that they got 7. They did. Perfect. All right, let's check out B. B is 21 plus 3 squared over 3. What do we got going here? Well, we've got actually the same operations here, believe it or not. This right here is an exponent. This right here means divide. I know it doesn't look like it. And this right here means add. So we've got exponents, divide, and add. It's all the same operations as before. It just looks different. So what do? Well, I actually do 21 plus, I'm going to do that last. I've got 3 squared over 3. Do I divide or do I do the exponent? I do the exponent first. 3 squared means 3 times 3, so I'm actually just going to rewrite this as 9. This 3 squared right here, that equals 9. So I'm going to rewrite that as 9 over 3. 9 over 3 means division. So it's 9 divided by 3. It's 3. Plus 21 is 24. The answer is 24. Let's erase and make sure that that's what the book says it is. And it is 24. All right, third one's got some different operations in it. Some of the same, but some of the different ones. There's more of them. I'm going to rewrite my PEMDAS nice and neat. PEMDAS. I'm actually going to highlight again which operations I have here. Let's go look and change it to orange. I've got times, I've got exponent, I've got divide, and I've got add. Alright, so first things first is the exponent, so I'm going to do 2 to the third power. That's not 6. 2 to the third power means 2 times 2 times 2. That's 8. Now I'm immediately going to bring down the rest of my problem. I've got 6 times 8 divided by 3 plus 1. Now, I want to be clear about something. I'm not going to do 6 times 8 because multiply comes before divide. Multiply and divide go together. I know it kind of doesn't look like it according to my image, but if you go back to the first page of this lesson, 249, the third line down says multiply and divide in order from left to right. I'm doing 6 times 8 first because it's on the left. 6 times 8 is 48. I'm immediately going to divide by 3. 3 goes into 48 16 times, plus 1 I get 17. Check my work. The answer is 17. Alright, in the remaining minute or two that we have on this video, we're going to solve numbers 2 and 3. If you'd like to try them on your own first, you can. You can hit pause, and you can hit play when you're ready to check your answer. Alright, number 2. Off to the right here, I'm going to put my PEMDAS. And I've got 7 plus 15. Plus is near the bottom of PEMDAS. I've got times 9 squared. I'm going to do 9 squared first because here's my 3 operations I've got. I've got add, times, and exponent. So I've got exponent, multiply, and add. Exponent goes first. So I'm going to do 9 squared. 9 squared is 81. I've got times 15, and I've got plus 7. What comes first? Well, multiply comes before add. So I need to do 15 times 81. And I can't do that mentally, and that's not on my multiplication chart. 5 times 1 is 5. 5 times 8 is 40. I'm in the tens place, so I put a 0 as a placeholder, and I go 1 times 1 is 8. And 1 times 8 is 8. And I add those up, and I get 5, 1, and 12. And so this answer right here, 15 times 81, is 1,215. And all I have to do now is add 7. Adding 7 to 15 is 22. So the answer is 1,222. All right, one more, number 3. $220 minus 450 divided by 3 squared. What are my operations? I've got parentheses, exponents, multiply, divide, add, and subtract. My operations are subtract, that's way down here. I've got divide, that's right here, and I've got an exponent, that goes here. Exponent goes first, so the 3 squared means 3 times 3, that's 9. And divide comes before subtract, so I'm going to divide now. 450 divided by 9. It's easier than it looks. Does 9 go into 45? It does, 5 times. With the 0 makes it 50. Can you check that? Of course, 450 divided by 9 is 50. Now I've got 220 minus 50. 0 minus 0 is 0. 12 minus 5 is 7, and 1 minus nothing is 1. It's 170. That's the answer. All right, great job. You're done with the first 2 pages of this lesson.